Hi, and welcome back to the Low Level Devil channel's OS development with the Linux kernel series. In the previous video we started by making a simple shell which we called lash, short for lame shell, because it doesn't do too much. In this video we'll expand on that and go over how to allocate memory using syscalls. So let's get started. Okay, first we're going to go to this Linux syscall table, and this is the syscall we want, break. It takes a unsigned long break, which is the new break of an application. So let's create a syscall for that. It's going to return a void pointer, call it sysbrk, and it's going to take in a void pointer. And simply return syscall sysbrk and pass in that pointer, and then 0 for everything else. So now let's go over what this brk actually is. So I'm going to draw a little map of the Linux memory, virtual memory space for a process. It's separated into several different sections, which I'll go over here and explain the need and the usage for break. So these are all the different segments of memory. Alright, up to here. So now this first section is the text section. That's got all your code in it. The next section is the data section, which has variables, and BSS, which has static variables. And then we have the heap. And now this section is invalid, inaccessible for your application. And then finally at the very end we have the stack, because the stack grows downward from the top. So this little section right here, this is the break. That's the end point of the application. So let's say this one is at 0x1fc0000. So this is how you grow the heap by using this syscall. So let's say you wanted to do a break call saying we're going to set the new break to, well, setting it to 0 is going to actually return that value first. So if you want to know what the current value is, you set it to 0. So if you want to change it, you want to set it to the current value plus an offset. Here's 4K. So that will then return the new offset, which is 1FC1000. So that will take this end section here, move it forward a little bit, and now that's the new end location, and you can use the memory in that byte section that you just changed. So you would start your memory read, your memory writes at 1FC0000 and can go all the way up to 1000. So I'm going to create a couple more utility functions that I want to use in Lash here. These are simple C functions, so I won't go into great detail on them since it's just plain old C. So this is just going to be a simple function to check the position of a character in a string. I'm just going to loop while the current character we're on is not 0. And if we hit a space, or if we hit a C, I'm using it for space normally, but if we hit that character, we return that position. So if it's not found, we return -1. I'm going to create a hex stir to ulong, so that when you type in a hex string, we can convert that to a number. So first I'm going to create a little hex char list. So 0, 1, 2, 3, 4, 5, 6, A, B, C, D, E, F. So now we'll take the result, start it off at 0, and we're going to loop while the current value at the S pointer is not 0. I'm going to result times equals 0x10 because it's base 16. So now we're going to add the position of the character that we're on. So if we're on 0, it's going to return the position 0. If we're on F, it's going to return the position 15. Alright, and then we return the result. And now we're going to do the same thing, but we're going to do one for an integer. Takes in a char pointer. And we're using a bool here, so I included this std bool, since that's now a part of C. So we have this bool negative equals, now if the first value of S is a minus, then we're going to set the negative flag. So, and if the negative flag is set, we want to increment S, so we start at the second character. So now again we're going to just loop just like we did in this one, but this time instead of 0x10, we're just going to do 10, because we're in decimal now, not in hex. So that's really, alright, let's put this variable up here, int result, and instead of going by the character pause in this string, we're just going to use the ASCII value and subtract it from the ASCII value of 0. Now we'll return result. If it's negative, we want to return negative result. If it's positive, we just return result. Alright. Now we can take these functions and add them to our header file so we can use them. And use the extern keyword. And we need the sys one too, sys break. So now we can start using this code in our lash. First I'm going to create a variable here so we can get our current break. So I'm going to set it to 0 at the start, and then as it boots up, we're going to grab that value from the sys break call. So we call sys break and pass in 0. That'll give us the current value of the breakpoint. And let's put this above here, so we'll print it out. And actually, to print it out, I included some code here for a printf function. And I'm not going to go over this in depth. I didn't actually write this code. It's written by this fellow here. And back in 2004. And I just have some customization in it. I'm using this put console instead of put C. I have a sys write to put console, and actually change this to, so it should be the printf file descriptor I'm creating by opening the dev console. Right here, yeah. So we call sys open for the dev console to create that file descriptor and write each character to that. And you can just pull this right out of the GitHub page. So I'm going to call printf, and we'll say the current break is %x, so that'll show us the hex value of the current break. Right, now I want to take the code out of this while loop, and I'm going to create an external function called process command. So we're going to take in the command that the user typed. Now we want to separate it out into a command and an argument. So we're going to get the position of the space in the command, Now if there is a space, then that end won't be -1. So if it's not -1, first thing we're going to do is set the command end to 0. So when we look for use the string compare, it will treat that as that's just the command. And we'll now set the argument to command plus end plus 1. So we don't want to start at the space, we want to start at the next character. And again, you need some bounds checking on all this stuff, but for the purpose of this video, I'm just showing you the simple way of doing it. So we're putting our reboot command up in here in our process command function. I'll just replace this here with process command and pass in buff. Alright, so now let's add a couple more commands here. So we'll start off with the break command. Now a break command takes one argument, and that's the value of the size that we want to change it to. So we're going to start size 0. If the argument is passed in, we're going to use our stir to int function to get the size. And the command will look like this: brk space and then a size, 4096, that's 4K. That's put into the size variable. So now what we're going to do is say we want to set the new value for the break is equal to, first we're going to cast it to a void pointer, because we're using unsigned long so value to make the math easy. So we take the current break plus size. So that's going to be the new value for our application break. And the address is going to be sysbrk new val. And that's always going to just return the new value that you passed in. But we're going to print it out just so you can see. So brk %x equals %x, and we'll pass in new value and address. Alright, so next, actually we're going to set the current break to unsigned long sysbrk 0 again. Make sure we update it. Alright, so that'll increment the break by the size and update it. So now the next command we're going to do, we want, since we are allocating memory, we want to store some data. So let's create a store method. Store method's going to take, store command, sorry, is going to take 2 parameters. So let's say we got the size here. Actually, hold on, let's see. Let me just start off by saying end stir pause argument 0. So we want to, since it's going to be 2 parameters, we want to get the end of the first parameter, which we're going to keep in arg, and we're going to use value as the second parameter. So we're doing this the same as we did up here. So this is going to be the second argument. And let's change this. So when we call store, we're going to add address and then space value. Address is going to be in hex, and value is going to be just a regular number. So an example will be store 1CF000 and then the value 12345. So address, again hex, and value is going to be base 10. Just to make it a little easier to read. Alright, so now what we want to do is say the address is the hex string to ulong function we created. The argument, that's the first argument. And then end stir to int is the second argument, where we put in val. So now what we want to do is just, first we'll print this out. So we'll say storing the value at the address. just so we make sure that code works as we expect it to. Now what we're going to do is create a pointer, cast that address to an int pointer, dereference that pointer, and set its value to n. So essentially this is writing to that location in memory. Now we need to fetch it too, so we'll create a fetch command. Fetch is going to be much simpler. Just say fetch address and it's going to return you the int value at that address. So again, we want to grab the address using the hex stirred along. And create a pointer to that address and dereference it to get the value, which we're going to print here. We'll say fetch value from address. Dereference P and pass in the address. And we can update our version number, so we're at version 0002. Go to the mylib. Let's make clean and make that. I think we can ignore these errors here, or warnings. It's just casting. And sudo make install. Now we'll go to the lash, make clean, make, and we have an error. Looks like I forgot to include the printf.h. So I'll go ahead and add that at the top. And again, you can get this printf code on the Git page, which I'll put in the comments section. So make clean. Let me add a cast here just to get rid of this warning. And sign long. Make it and sudo make install. Okay, and now there was an error I made in this utility function. This result should be 0 to start with, not that unreferenced value. Okay, so we'll rebuild that mylib. Make clean and make and sudo make install. Oops, messing up the password here. Alright, let's try that again. There we go. Alright, that's installed. Do the same for lash. And now we can reboot. Okay, now it's booting up. I'll go to my OS. Resize it some. Alright, we see initializing, and there we go, lash 2.0. So we see the break is 166D000. If we just type BRK, it's going to do the same thing, return it. It's the same as typing break 0. So now let's store a value. Let's try to store a value at 166D000. We'll say 12345 is the value. And what do we get? We get a segfault. The reason for that is because 166D000 is actually the end of the application, so you can't write at it. What we need to do first is allocate some memory, and then we'll be able to write to that. So let's reboot. Again, now we got a new value, and this is randomized by the Linux kernel to start break value. So let's increase it by 4096 by 1K. So now we can store at that EC000 value. We'll store 12345, and there we got it. Now we'll store at the next 4 bytes, which is the size of an int. We'll do 54321. Now we can fetch those values. Fetch the value at the first one. So you see, fetched 12345. Fetch the value at the second one. That's 5, 4, 3, 2, 1. There you go. It's storing and fetching memory. That's pretty much the basics of it. But let's do a little more here. Let's call break 1. So a little bit about this. So we're not actually allocating 1 byte of memory. It's actually going to allocate 4096. Even though it says the break point is now D001, it's actually E000. So we can write a 4 byte value to that, which our integer is. And the reason for this is Linux will actually allocate memory in pages. So we're going to write 6, 7, 8, 9 to that. And we'll go to the next 4 bytes, which is past the end of the break according to the break command. So you would think it would be a seg fault, but it's not. So we can actually write to that D004 and we can fetch that value, and it's fine. It's because the actual endpoint is E000. So let's try to write to E000. 1, 2, 3, 4, 5. There you go. We have a seg fault. And that's because that's the actual end of it. So the libc and other libraries that allocate memory will actually allocate 4K at a time. And when you call the syscall, if you pass in 1 byte, it's not going to allocate 1 byte. It's actually going to allocate 4096 and return you the right value. So you typically want to do that when you're writing your own allocator. But I just wanted to give you an idea how that works. So I think this is a good stopping point, giving you the idea on how to write to memory, how to allocate memory and read from it using system calls. So I hope that you enjoyed this video, and if you do and you learned something, like, subscribe, comment with any questions that you have or comments, and thanks for watching.